Hello all, I am Baki Lakshmi.
Myself, Jeevarathina.
We are from Milam Engineering College doing Bachelor of Engineering in the stream of Electronics and Communication Engineering final year. We have done a project called IoT based home automation for Emertxe Information Technologies internship on IoT. Now we will see the table of contents. The first one is topic learned during internship and what is IoT, IoT architecture, what is embedded system, project requirements, and the screenshots, conclusion, and finally we will see the implementation video. And the first one, the topics which are learned during the internship are C programming. In C programming, we have learned many things like keywords, basic data types, operators, conditional and looping concept, arrays, pointers and functions, storage classes, etc. And the next one is C++ programming. We have learned about OOPS concept and and the introduction to IoT and the definition and architecture of IoT and the introduction to the embedded system and the types and components of embedded system and the peripherals like LED, Arduino, CLCD, ADC, etc. Now we will see the peripherals required for the project. First one is LDR sensor, which is used to read the sensor values and based on the reading vary the brightness of LED called garden lights. And the temperature system, it consists of heater, cooler and LM35 temperature sensor. We can read the temperature from the temperature sensor. And the serial temp, we can read the volume of the water in the tank through serial communication. And then we are going to see about what is IoT. The Internet of Things is the network of physical objects that contains embedded technology to communicate and sense or interact with their internal states or their external environment. These devices ranges from ordinary household objects to sophisticated industrial tools within more than 7 billion connected IoT devices today. Experts are expecting this number to grow to 10 million by 2020 and 22 billion by 2025. By means of low cost computing, the cloud, big data, analytics, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connected things. The physical world meet the digital world and they cooperate. And then what is embedded system? Any combination of hardware and software which is intended to do a specific task can be called as embedded system. It consists of three parts, and that is software, firmware and hardware. Unlike computers, embedded system perform few specific limited tasks. Embedded devices have peripherals such as serial communication interfaces, synchronous serial communication interface, universal serial bus, multimedia cards like SD cards, compact flash, etc. Then this is the basic diagram for embedded system, how it is working, and then the project requirements. The control garden lights on the basis of sunlight intensity. Lesser the sunlight, brighter will be the garden lights. Temperature system control. Switch heater and cooler on or off remotely. Switch heater off automatically if temperature indoors exceeds 35 degrees Celsius. Water tank control, switch inlet and outlet valve on or off remotely. Switch inlet valve off automatically if the tank fills up. Switch inlet valve on automatically if volume of tank drops below 2000 liter. And then these are the requirements. The hardware requirements for the projects are Arduino, EDHW 5500, PCF 8574, temperature sensor, LCD HD 44780, LDR sensor, LED. And the software requirements are Arduino IoT, which is used to code, and PiximLab for simulation, null modem emulator to configure ports of serial remote LAN, and Blink IoT app, which is a cloud server. And what is Arduino UNO? Arduino UNO is based on an Atmega 328P microcontroller. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input pins, shield and other circuits. The Arduino UNO includes 6 analog input pins and 14 digital pins and a USB connector, a power jack and an ICSP. header. It is programmed based on IDE. It stands for Integrated Development Environment. It can run on both online and offline. And then ETH W5500. The W5500 chip is a hardwired TCP/IP embedded Ethernet controller that provides easier internet connection to the embedded system. It enables the user to have the internet connectivity in their application by using a single chip in which a TCP/IP stack, and it supports power down mode. It supports wake on LAN over UDP. And then this is the screenshot for Visnet W5500 Ethernet Shield, and then the PCF8574. It is a silicon CMOS circuit. It provides general purpose remote I/O extension for most microcontroller families via the two-line bidirectional bus. This device consists of an 8-bit quasi-bidirectional port and an 12C bus interface. And then the temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and convert the input data into electronic data to record, monitor, or signal temperature changes. And then the LCD HD4470. It is a dot matrix liquid crystal display controller and driver. LSI displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. And then the LDR sensor is a component that has a variable resistance that changes with light intensity that falls upon it. This allows them to be used in light sensing circuits. And then this is the screenshot when we load the X file. And then the LDR is high, the LED will be turned on. When the LDR is low, the LED will be turned off. And then in this the cooler is turned on and this cooler is off. And the screenshot shows the heater is on and this shows the heater is off. And then the inlet valve is on in this screenshot and the inlet valve is off in this screenshot. And in this the outlet valve is on and then outlet valve is off. And this is the notification of heater temperature. And then the heater will automatically turn off when the temperature rises above 35. And in this shows the notification of water level, and this shows the water tank is full, inlet valve will automatically turn off. And in this the water volume level is shown. And now we will see the um, implementation video. um, these are the codes that we have done. We have included all the header files and libraries into it. Then we are writing an authentication code in Blink Cloud. Then we have initialize and declare the variables. And we have mentioned different functions and definitions. Using the Blink app IoT, it is used to display the cooler is on and cooler is off, and also heater. And now we will see this in the Big Sim lab. It consists of blinking of LED, the help of LDR, and the light turns off when we lower down the resistance, and when the resistance is high the light will on. And we have a Blink app. By the option of cooler, we can see the option of cooler. We turn on it shows that the cooler is on. When we click on off, the cooler will stop, and in the display it shows the cooler is off. And then the heater, when the heater is on, the temperature will increase, the heater turns off when the temperature is 35 degrees, and we get a purple message that the temperature is above 35 degrees Celsius, and turning off the heater, temperature is above 35 degrees Celsius. When we increase the temperature, it will show the temperature is 35 degree above Celsius, and the heater is turned off, and the cooler is also turned on, and the cooler will off when the temperature is less. And this shows the indication of water level. These are the workings of water level in the tank. When we turn off, the outlet is off, and the inlet will be off when it completes 3000 liter, and we can turn on the outlet whether the water is decreasing. And in the blink app, it shows that the water level is decreasing, and it gives a notification. It shows that the water level is less than 2000, inflow is enabled, and the inflow needs to be enabled. When the water level is full and the water inlet is disabled. Then the conclusion. Using Blink IoT application and PixSim Lab simulator, simulated home automation where LED temperature system, serial tank resemble light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet valve, outlet valve. Card widgets to display the temperature and volume of the water. And then finally, I thank Emertxe Information Technology for taking us an intern and doing this project. Thank you.